Good day, my fellow nerds. I am going to talk to you about Bubblesort today. I think we're going to have some fun. We're going to actually pull up some code. We're going to write it in JavaScript. Bubblesort's such an important algorithm for you to know for the fundamentals of computer science. And with the implementation I'm going to show you, I think it's a little more optimal than some of the traditional ones. We're going to go through a little bit of whiteboarding phases, and then we're going to go into the actual code in Visual Studio Code. Now, if you're going into an interview and you just need brushing up, or if you're a new coder, I really think this video is going to provide some benefit to you. And if you happen to like it, make sure you give me a thumbs up and please subscribe. Take care, guys, and let's jump right into it. Okay, so with Bubblesort, it's actually going to be pretty easy just to show you a simple example here. So we're going to use the number 2, 1, 3. So imagine this is an array, and we're indexing into it. We'll talk more about how the code looks in a little bit, but typically what we're going to try to do is we're going to actually have the smaller values bubble up to the front or to the left. Now, if you were to look at them from the example of 2, 1, 3, we'd have the smaller numbers be bubbling up this way. You can also do the bubble sort to have the larger numbers, and it's a matter of just changing the way you do your checks. But for this case, we're going to be going in increasing order. So our goal is to get this to 1, 2, 3. So bubble sort, the way that I like to always do it, is I like to iterate over everything until there are no more changes. So let's just start with that, right? So we have a 2 and a 1. We know that 1 is less than 2, so we want to bubble that forward. So we do a very simple swap there. So now this becomes 1, this becomes 2, and this becomes 3. Now we can see this is sorted, but the program won't know that yet because it has no idea what is actually behind it. So we're going to check 2 and 3, find that that is correct, and that iteration through, that loop through will actually end. Now it will actually, in our code, go through a whole nother time. So we'll actually go and check 1, 2, 3 again. So we'll check here, see it's good, so we'll check there. We'll do check here, see that's good. And then we can know that we're done at that point. Super easy, right? Let's do a little bit harder example. I always like to do one that's completely in reverse order just to kind of show the worst case scenario here. So let's go through. We'll do the very first check. We'll do the swap. And we'll do another check here. We'll do the swap. So I have 3, 2, 4, 1. We'll go through again, we'll do another swap here, because you see that 1 is less. So we'll do 3, 2, 1, 4. And then we're done with that loop, so let's start another loop. We start here, we end up with 2, 3, 1, 4. We do a loop check here, we end up with 2, 1, 3, 4. We do a check here, we find that that's correct. So we start another loop, and then we find, instead of writing that, I'm just going to show you here. So we know that we got to swap these two, and we're going to end up at 1, 2, 3, 4. We're going to find that 2 and 3 are fine, 3 and 4 are fine, but we did have one swap this one. So we are going to, in the algorithm I'm going to show you, we are going to go through it again. So we would do another check where we go 1 and 2 is good, 2 and 3 is good, 3 and 4 is good. So you see, this is a worst case scenario where it's in complete opposite order and everything has to bubble up. But as you can see, the algorithm works pretty simply just by doing swaps and compares. All right, let's jump right into the code now. Okay guys, now that we're on the computer, you can see that I've got Visual Studio Code opened. I'm writing in JavaScript. I have 3 sample arrays here that I'm going to use for testing. I've stubbed out a couple things here for my results, and I've stubbed out a function that I want to use to actually write the bubble sort algorithm. So one of the first things I do is I really like the early out example. So what I do is I do if finished is equal to false, and then I do while not finished. I make a loop here that basically is going to continue iterating through over and over and over again until there is no longer a swap. So let's just write that out. I'll show you what that looks like. So first off, what I would typically do here is I set finished equal to true, because what I want to do is only set finish back to false if there is a swap. So let's do a for loop. I is less than ar.length. So very simple for loop there. Then what I'm going to do, and as you can see, I misspelled length here. The other thing that you may notice is I've got I is less than r.length when I'm always going to be looking one ahead. So what I actually need to do here is make this -1, because we don't want to go to the full end of the array. We want to go to 1 before the end and then be able to check that one. So very simply, I do if arr.I is greater than arr.I plus 1, we are going to swap here. To swap, typically just have a temp variable. We'll assign it to arr.1.I rather, and then we will say arr.I is equal to arr.I plus 1, and we'll do arr.I plus 1 is equal to 10. So my swap is complete. We're missing one additional thing here where we actually need to set finished equal to false. And that's important because we now have made a change in this iteration, so we know for sure that we need to go through it at least one more time. So at the very end of here, outside this loop, I'm just going to do return R. Now, let's very simply go through here and check. So let's do console.log result1, and we'll do a console.log result2. And to run this in Visual Studio Code, it's pretty easy. I don't even have to set up a configuration. I can just hit play there. And as you can see, both of them ended up being completely sorted, which is pretty awesome. Now, these are very small arrays. So what I've put together here is a little bit more complicated of an example. I've got a bubble sort ascending, and I always typically do that because when you're writing a bubble sort algorithm, you could have it ascending or descending. So I typically name it that way. And as you see, this is pretty much identical. I've got a few console logs here, which I can show you how that works here in a second. But what I really did here is I wanted to show you what it was like for larger arrays and how much time it takes, because the complexity of bubble sort is actually rather high, meaning the larger the array size, the larger the amount of time at an exponential rate. So this is actually big O of n squared, n being the size of the array. Now, in a perfect case where the array is already sorted, you can actually get out in n times. But in a horrible case where the array is completely reversed, kind of like what I showed you in the earlier example, you will end up with n squared time. Okay, so what we're going to start by doing is we're going to run 100, and we're going to hit play. And we ended up with 3.107 milliseconds. And you'll get variations of that as you run it again and again. So I've got 1.885, I've got 1.95, and the reason for those variations is, first off, we're randomly creating it, so we could be finishing early in some cases. But the idea is that it's fairly fast. So for 100 items, you can do that fairly efficiently. Now, let's go to 1,000 items. Save it and rerun it. So we're up to 5 milliseconds. So you can imagine 5 milliseconds when especially when you're dealing with things like video games where you need 60 FPS, 5 milliseconds is unacceptable for sorting 1,000 values. So we'll talk about other ways to do that quicker later. But I wanted to give you the idea of 1,000, and then, so you see that from 100 to 1,000, it doubled. Now, some people might think it would double again to 10 milliseconds for 10,000. But let's just take a look at what these numbers are actually going to be. 378 milliseconds. And if I ran it again, it's probably going to be in that same realm, 365. Now this gets to be almost consistently a third of a second for this code that I'm running here. Completely unacceptable in anything that needs to be performed as critical. Now let's do something really fun and go to 100,000 and run that. Now we're going to sit here and talk for a little bit because this is probably going to take not only a second, but it's actually going to take somewhere around 20 seconds would be my guess. And again, it depends on the array that was generated, when it finishes, and maybe even like the speed of my computer, that's going to have an impact on it too. But as you can see, it's still running. Now, could you imagine playing a video game and have to have something sorted, or go to a website and have to wait this long a time to sort 100,000 objects? You can think of numerous examples of 100,000 items of data. So in this case, we ended up with 38 seconds, almost 39. So as you can see, Bubblesort is efficient for anything under about 100. And as you can see, like if I did a 10, for example, 10 is like pretty equivalent to 100. Should get another, yeah, so 10. And a lot of that is, I'm booting up Node, there's a lot of stuff happening, so there's going to be some inconsistencies there. Plus the early out option. Now, if you were to go through here and write this a different way, where you didn't have this early out, where instead you iterated over X number of times where X is the length of the array, then you'd end up with a much worse case for some of the better sorted arrays. But anyway, hopefully this gives you an awesome idea for how Bubblesort actually works. The code here is so simple, and like I said earlier in the video, you should be able to write this on a whiteboard in an interview. You should be able to write this in your sleep. If you're sorting 5 or 6 or 7 items and you don't know, and you know for sure that it's not going to be larger than that, then you absolutely can use Bubblesort for that. If you're doing a ton of data, a ton of items, Bubblesort is not the right answer. Another thing to note is it's n squared big O complexity. So as the array size goes, the time that it's going to take is exponentially growing. So just remember that, and I hope that this helps everyone that watches this. So have a great day, and see you guys next time.